Hello Kagamas! Let's do this! Journey with me as we face, overcome, and befriend the challenges ahead. We can because we are Mathematics Yan. I am Teacher Andrew, your soulmate. Allow me to guide you in learning the different concepts and skills in Mathematics 9. When you were in grade 7, you must have learned about linear equations in one variable. I have here 3 bricks, and written on each is an equation. We will identify whether the equation is linear or not. The first brick displays the equation 9x plus 15 equals 91. Is it linear? Let's see if you are correct. Alright, so if you said that it is linear, you are correct. The second brick displays the equation 2x plus 9 equals 20. Is it linear? It is also linear. Now, the last brick displays the equation 5x squared minus 23x equals 19. Is it linear? Clearly, that isn't a linear equation. But do you know why? It is because the highest exponent of the variable in the equation is 2, and we call such an equation a quadratic equation. In today's episode, we should be able to differentiate quadratic equations in one variable from linear equations. Write such equations in standard form, identify the value of the coefficients a, b, and c, and lastly, determine whether a situation or word problem illustrates a quadratic equation. Since we should not bury the skills and concepts we have previously learned, we say, past not dead. To recall a skill you learned when you were in grade 7, let us answer this activity. Does this task look familiar? I hope it does, because you were taught by your grade 7 math teacher how to multiply polynomials. Let us answer item number 1 in 5 seconds. Ready? Let's do this! And time's up! Applying the distributive property, we should get 2x squared minus 7x as the answer. We now answer item number 2 in 7 seconds. Ready? Let's do this! And time's up! Here, we use the FOIL method since the given factors are both binomials. We shall get x squared plus 9x plus 5x plus 45. Since there are similar terms, we can simplify it into x squared plus 14x plus 45. Another 7 seconds for item number 3. Ready? Let's do this! Time is up. The answer is 2x squared plus 5x minus 3. Item number 4 presents the case square of a binomial. For 5 seconds, let's do this. Time's up. The answer is a perfect square trinomial in which the first term is the square of the first term in the binomial. The last term is the square of the last term in the binomial, and the middle term is twice the product of the terms in the binomial. Hence, the answer is x squared plus 12x plus 36. The last item presents the case sum and difference of two numbers. For 5 seconds, let's do this. Time is up. Instead of applying FOIL method, we simply multiply the first terms and then the last terms. Thus, the answer is 25x squared minus 16, a difference of 2 squares. Now let's take a look at all the answers in the activity we just did. All of them are polynomials of degree 2. Now, if we set each equal to 0, what do we get? Quadratic equations in standard form. They are in standard form because 1. The terms are arranged in descending powers. 2. The polynomial is set equal to 0. In general, a quadratic equation in one variable is in standard form if it is of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a should not be equal to 0. Ax squared is the quadratic term, or the term of degree 2. Bx is the linear term, or the term of degree 1, while c is the constant term, or the term of degree 0. Note that a, or the leading coefficient, should not be equal to 0. Otherwise, the equation will be linear since any quantity multiplied by 0 is equal to 0 and thus can be omitted already. Therefore, there are quadratic equations where b is equal to 0 or there is no linear term. They are of the form ax squared plus c equals 0, just like 25x squared minus 16 equals 0. On the other hand, there are those where c is equal to 0, or there is no constant term. They are of the form ax squared plus bx equals 0, just like 2x squared minus 7x equals 0. However, the standard form of a quadratic equation is not unique because of the following cases. Case 1. Considering symmetric property. Say for instance, we are to write the equation 5x minus 3 equals 2x squared in standard form. One way to do it is to apply the subtraction property of equality, so that the left side of the equation contains the quadratic term and the right side is just 0. Then, we arrange the terms in descending powers. Hence, the equation negative 2x squared plus 5x minus 3 equals 0. Here, the values of the coefficients are as follows. A is negative 2, B is 5, and C is negative 3. The other way to write the given equation in standard form is by applying the symmetric property, after which we can apply other properties of equality to place all the terms on the left side of the equation, and thus the right side is just 0. It so happens that the terms are already arranged in descending powers. Hence, 2x squared minus 5x plus 3 equals 0 is also the standard form of the equation 5x minus 3 equals 2x squared. Here, the values of the coefficients are as follows. A is 2, B is negative 5, and C is 3. So, the equation 5x minus 3 equals 2x squared can be written in standard form in two ways. First is negative 2x squared plus 5x minus 3 equals 0, and 2x squared minus 5x plus 3 equals 0 are considered equivalent quadratic equations. Case 2. Considering greatest common factor of the coefficients. Our example here is the equation 3x squared plus 9x minus 12 equals 0. Although we can see that the equation is already in standard form, the coefficients 3, 9, and negative 12, which are the value of a, b, and c respectively, are all divisible by 3, which is their GCF, or greatest common factor. So, dividing both sides of the equation by 3, we get x squared plus 3x minus 4 equals 0, which is also in standard form. Here, the value of the coefficients are as follows. A is 1, B is 3, and C is -4. Notice that their GCF is already 1, therefore, they are considered relatively prime. So we say that 3x squared plus 9x minus 12 equals 0, and x squared plus 3x minus 4 equals 0 are equivalent quadratic equations. But for the purpose of having to think of only one way to write the standard form, all answers will be expressed in the form ax squared plus bx plus c equals 0, where the leading coefficient or the value of a must be positive or greater than 0. And all non-zero coefficients are just divisible by 1. How are you holding up? I hope everything is fine. So, to make sure that we are on the same page, that we understand what has been discussed, let's answer another activity. So we say, Math the Moment! In this activity, we have to write the given equation in standard form and identify the value of A, B, and C. Again, A should not be negative. It should be positive or greater than 0. And all non-zero coefficients are just divisible by 1. Item number 1 for 15 seconds. Let's do this! And it's time to reveal the answers. See if you got them all right. The standard form is 2x squared minus 2x plus 7 equals 0. The coefficients are as follows. A is 2, B is -2, and C is 7. Let's answer item number 2 for 15 seconds. Let's do this. Time up! The answers, standard form, is x squared plus 3x minus 3 equals 0. The coefficients, A is 1, B is +3, while C is -3. Item number 3 is next, for 30 seconds. Let's do this. And exhale. Here are the answers. Standard form, x squared plus 9x plus 20 equals 0. Coefficients, A is 1, B is 9, while C is 20. We're ready for another one, aren't we? Item number 4 for 30 seconds. Let's do this. Armpits up. Check your answers. Standard form, x squared plus x minus 2 equals 0. A is 1, B is 1, and C is -2. Last item for 30 seconds. Let's do this. And boom! Pen or pencil down. The answers are, the standard form is x squared minus 2x minus 5 equals 0. So A is 1, B is negative 2, and C is negative 5. Let's take another look at the answers. We expressed the standard form in such a way that the leading coefficient, or the value of A, is positive, and all the non-zero coefficients are relatively prime. To enhance our understanding of quadratic equations, we will learn how to represent situations using equations and be able to determine whether the situation illustrates a quadratic equation. Let's read the first sample situation all together. If the square of a number is added to 8 times the number, the result is 100. Since there is no specified or indicated variable, we will just use x. Square of a number can be translated as x squared. Added to in symbols is just plus sign. 8 times the number can be translated as 8x. The result is 100 in symbols is equals 100. Hence, the situation can be expressed as x squared plus 8x equals 100. Obviously, the equation is quadratic since the highest exponent of the variable x is 2. Now, let's write it in standard form by applying the subtraction property of equality. The resulting equation is x squared plus 8x minus 100 equals 0. Alright, it's time to practice the skill we have just learned. We say, math the moment. Represent each situation using an equation to determine if it illustrates a quadratic equation. Item number 1, let's read it all together. Mrs. Salome charged 3,655 pesos worth of groceries on her credit card. The balance of her credit card after she made the payment is 2,450 pesos. For 30 seconds, let's do this. And time is up, so put your pen down. Do you think you got it right? Let's see. The situation can be represented by the equation x minus 3,655 equals 2,450, where x was the balance in the credit card before Mrs. Salome made the payment. And since the variable is raised to 1, the equation is not quadratic. Thus, the situation does not illustrate a quadratic equation. Item number 2, let's read it first. The dimensions of a cube are reduced by 5 centimeters on each side, and the new surface area becomes 48 square centimeters. For 30 seconds, let's do this. Stop right there. Whether you did it right or wrong, you deserve a hug from yourself. Now, let me discuss this first. A cube is a solid figure that is made up of 6 faces that are all squares. The dimensions of a cube are reduced by 5 centimeters. This means that from the original side length, which is unknown, it is shortened by 5 centimeters. thus the change from s to s minus 5. The formula for the surface area of a cube is, given by the equation, SA equals 6s squared, where s refers to the side length of the cube. The new surface area becomes 48 square centimeters. In symbols, SA equals 48, and 48 must be equal to 6 multiplied by the quantity s minus 5 squared. We should realize that both sides of the equation are divisible by 6. Dividing both sides by 6, we should get 8 is equal to the square of the quantity s minus 5. Squaring the binomial on the right side, the equation now becomes 8 equals s squared minus 10s plus 25. We see that the highest exponent of the variable is 2. Thus, the situation illustrates a quadratic equation. Combining similar terms and writing the equation in standard form, the resulting equation is s squared minus 10s plus 17 equals 0. Item number 3. Let's read it all together. The area of a rectangular floor is 864 square meters, and its perimeter is 120 meters. Let's do this! And time is up. Let me explain and share the answer. First, let's recall the formula for the area and for the perimeter of rectangle. The area is 864 square meters. It just means that 864 is the product of the length and the width of the floor. The perimeter of the floor is 120 meters. This means that twice the sum of the length and the width is 120. And this also means that the sum of the length and the width is 60. Say we express the length in terms of the width. So we have the equation 60 minus W equals L, or L equals 60 minus W. Now by substituting 60 minus W in place of L in the equation 864 equals L times W, it is going to look like this. 864 equals 60 minus W times W. Let's multiply the quantities on the right side. So we have 864 equals 60W minus W squared. So clearly, the equation is quadratic. Therefore, the situation illustrates a quadratic equation. In standard form, it can be written as W squared minus 60W plus 864 equals 0. Kagamath, lest we forget what we have just learned, let's have a quick recap through this activity we will call You Complete Me. Just supply the missing part of each statement. Let's have number 1. A linear equation is of degree 1 while a blank is of degree 2. Answer: quadratic equation. Statement number 2. The standard form of a quadratic equation in one variable is blank, where a, b, and c are real numbers, and a should not be equal to 0. Answer: ax squared plus bx plus c equals 0. Third statement. When expressed in standard form, where a is positive and all the non-zero coefficients are relatively prime, the equation 10 equals 4x multiplied by the binomial 2x minus 3 is written as blank, and the value of a, b, and c are blank, blank, and blank respectively. Answer: 4x squared minus 6x minus 5 equals 0. A is 4, B is -6, and C is -5. And that's it, Kagamath. I hope today's episode has been very helpful. This is your Solvemate, Teacher Andrew. But before we go off air, let me share one of the mottos I hold on to as a mathematics teacher and learner at the same time. Do not hate what you do not know. See you again next time as we face, overcome, and befriend the challenges ahead. We can because we are Mathemati Isinian.